This is chapter 6-5, Trapezoids and Kites. Please copy your cuts. This will be video 1 of 2 for chapter 6-5. We'll start with kites. A kite is actually a quadrilateral. Remember, quadrilateral is a 4-sided polygon. A kite has 2 pairs of consecutive sides that are going to be congruent, but the opposite sides will not be congruent. For example, here's a kite. We have 2 consecutive sides that are congruent. You have to find the 2 consecutive sides. I don't mean if I call this kite M, L, B, C, you see ML is congruent to LB. However, because they are consecutive, remember the word consecutive means next to, okay? Although LM and CM are consecutive or next to one another, they are not congruent. You need to make sure you look at which 2 legs are congruent to, consecutive legs are congruent to one another. So ML and BL are consecutive congruent legs on a kite, and BC and MC are the 2 consecutive second pair of congruent sides on this particular kite. Alright, so we have 2 pairs of congruent consecutive sides. The first pair, the first 2 that are congruent are, again, ML and BL, and then the second pair, or the second 2 legs that are congruent are BC is congruent to MC. Alright, so that's a kite. Remember, the opposites are not congruent, so MC is not congruent to BL on a quadrilateral kite. Moving further, theorem 6-18, if a quadrilateral is a kite, then its diagonals are going to be perpendicular. So, I have kite ABCD, and you can see I've drawn the diagonal. The opposite of B is D, and then the opposite angle of A is angle C. So I've drawn in the diagonals. And what's special about the kite is that when I draw the diagonals, they will form perpendicular angles on the interior. Remember, perpendicular means all these interior angles are all 90 degrees. That's what's special about a quadrilateral kite. The diagonals will automatically form, the diagonals BD and diagonal AC will be perpendicular to one another, therefore forming 4 right angles. Again, the 2 diagonals, diagonal BD and diagonal AC, are perpendicular, therefore their interior will form 90-degree angles. Okay, you got to remember what diagonals are and what perpendicular means. Here's theorem 6-19. We have a pair of quadrilaterals, a kite, and then in this particular theorem it just says a quadrilateral is going to be a kite. Then you'll have exactly 1 pair of opposite angles that are congruent, right? So we know this is a kite because we see AB is congruent to the consecutive, remember, next to leg BC. Again, AB is congruent to CB. We see that there with a marker. And then the second pair, remember, you're going to have 2 pair of congruent segments in a kite. And the second pair of congruent legs are AD and CD. They are congruent to one another. Okay? Now, on the kite, the opposite angles will be congruent. It's only 1 pair. And the pair that will be congruent is the angle that's in between the 2 legs that are not congruent. AB is not congruent to AD. That means I'm talking about this angle A, and it's going to be congruent to the opposite angle C because the leg, it's in between the 2 legs that are not congruent. BC is not congruent to DC. So therefore I'm talking about this angle C. It will be congruent to angle A. Now watch. No, I cannot switch these. I can't make this stuff up and say, oh, angle B must be congruent to angle D. That's not true on a kite. How do I know angle B is not congruent to angle D? Because if I look at the 2 consecutive legs, BC and BA, they are congruent. That means the interior angle cannot be the angle I'm referencing. That's a no-no. So that's wrong. I chose the wrong two angles that will be congruent. It's not angle A, it's congruent to angle C. Again, I know it's angle A and angle C that are congruent, and remember, it's only going to be one pair, so angles B and D will not be congruent. However, angles A and C are congruent. How do I know to choose? Again, angle A and angle C. I know to choose them because, again, BA is not congruent to AD. That angle that is in between the two non-congruent angles. Okay, so I choose angle A because I see that the two segments that they're in between, they're not congruent. So segment BA is not, and if I said angle, please forgive me, segment BA is not congruent to segment DA. Therefore, I'm talking about this angle A, and it's going to be congruent to the angle C. It's opposite to it. Opposite angle. Now, what if angle A was not chosen? How do I know to choose angle C again? Because angle C is in between the two segments that are not congruent. BC is not congruent to DC. Okay, so that means I want this angle, and it's going to be congruent to the opposite angle A, and that's theorem 619. Moving further. All right, here's just what I stated. Angle A is congruent to angle B, and this is not what I want on here. Angle A is congruent to angle C. All right. Let's suppose I have a kite here, and I'll go back here. Whole lot drawn in here. And I'm going to let you copy this down while I'm writing here. Okay, let's suppose we want to find the length of BC. Okay, how can we do that? Well, so since this is a kite, and I know it's a kite because I see AB is congruent to BC, they're the same length, and they're consecutive next to one another. Remember, they have to be next to or consecutive. And CD is congruent to AD, they're congruent. That's the second pair of consecutive congruent segments. How can I determine the length of BC here? How do I determine the length of BC? Well, what do I know about a kite? I know that in a kite, because I've drawn the diagonals here, I know that the diagonals will be perpendicular, forming 90-degree angles. All these are 90 degree. Okay? Now, I see that this, if I want to call this M here, this point of intersection M, I see the length of CM is 3. I see the length of BM is 4. The question is, what's the length of BC? Well, what do I see? If I shade this here, I see that this is a right triangle. That's a right triangle. And if I move my right triangle over here, and I redraw CM, and I'm going to redraw the lines, I'm just moving it over, and that's B. CM was given as 3. MB is 4. And the question is, what's the length of BC? Well, if this is a right triangle, that means I can use the Pythagorean theorem. Remember, let's recall, that's A squared plus B squared is equal to C squared. Well, which one is our C? Remember, your hypotenuse is always diagonal the 90-degree angle, which is your BC. Now, I'm just going to solve by substitution. Okay, I'm letting A be the 3, so 3 squared plus the 4 squared is equal to C squared, which is your BC. So 9 plus the 16 is equal to C squared, and that's 25, and the square root of 25 is going to be equal to 5. So BC is equal to 5. Okay? Again, that was 9. I'm just bringing this portion right here, this line out. 9 plus 16 is equal to 25, which is your C squared. And I'll write it this way. So 25 is equal to C squared. Take the square root on both sides. and I get C is equal to 5, and C is also equal to it's representative of the length of DC. Okay? All right, next we'll look at quadrilaterals for trapezoids.